Hello and welcome to Solving for Solar, where today's topic is powers. If you've had any difficulties in the past with powers, then this is the perfect video for you. We're gonna go over all the rules and then give you examples going from easy to difficult, breaking down the concepts so they're easy to understand and easy to follow. Let's start off. So, starting off, what are the components of power? There's the base, which is the normal number, and then there's the exponent or index or power. But what do these base and exponents mean? So, if n is a positive integer, then a to the power of n is a product of n factors of a. That's the mathematical terms. Now let's break it down so that it's easier to understand. So, a to the power of n is a multiplied by each other n times. So, let's use numbers so it's easier to understand. Let's say we have 4 squared. Well, that's the same as 4 times 4. And I'm guessing you know that that's 16. Let's say we have 2 to the power of 4. That's the same as 2 multiplied by 2 multiplied by 2 multiplied by 2. So it's 4 2's multiplied by each other, which gives us 2 times 2, which is 4, times 2, 8, times 2, 16. Now that we have the concept understood, let's move on to how we add them, subtract them, multiply them, and how brackets work. Okay, so if m and n are positive integers, then if we're multiplying 8 to the power of m multiplied by 8 to the power of n, we'll get a to the power of m plus n. So to multiply the numbers with the same base, keep the base and add the indices. Let's use numbers because it's always easier to understand with numbers. Let's say we have 4 to the power of 2 multiplied by 4 to the power of 6. Okay, so what we do here is we keep the 4 and we add 2 plus 6, which gives us 4 to the power of 8. It's easy to understand. Now, to divide numbers with the same base, keep the base and subtract the indices. Let's say we have 5 to the power of 4 over 5 to the power of 2. Well, that's the same as 5 to the power of 4 minus 2, which is 5 to the power of 2. And make sure to note that a or the base cannot be 0 because that doesn't work. Okay. Finally, let's discuss when raising a power to a power, keep the base and multiply the indices. So, let's say we have 3 squared and it's all the power of 3. What we do here is we keep the 3 and then we multiply 2 and 3. So it's 2 times 3, getting 3 to the power of 6. In order to fully understand the concepts, let's take some examples. Okay, let's choose a random example. Let's go for B. So we have 3 squared times 3 squared. So we keep the base and we add the exponents. 2 plus 2, giving us 3 to the power of 4, which is the same as 3 multiplied by 3 multiplied by 3 multiplied by 3. So it's 4 3's multiplied by each other. So that's 3 times 3, which is 9, times 3, 27, times 3, 81. Let's take another example, G. So we have x power of 5 multiplied by x to the power of 6. That's the same as x to the power of 5 plus 6, which is x to the power of 11. Okay, before moving on, I'm going to give you a few seconds to pause, solve if you want the rest, so that you have some practice, because it's all about practice. These concepts are easy to understand once you have done some practice. And I'm going to give you the answer in 5, 4, 3, 2, 1. These are the answers. If you want to pause and check your answers. And let's move on to some other examples. Okay, so simplify using the index laws. We have, let's choose an example. Let's choose C. Okay, so for C, we have 5 to the power of 6 over 5 to the power of 4. That's the same as 5 to the power of 6 minus 4, because we subtract. Once it's division, we subtract. Multiplication, we add. So this gets us 5 power of 2, which is 25. Let's choose another example. We have, let's say, H. B to the power of 9 divided by B to the power of 4. That's the same as B to the power of 9 minus 4, giving us B to the power of 5. Same as the last time, I'm going to give you 3 seconds to pause and solve as much as you can. And then I'm going to give you the answers. 3, 2, 1. And these are the answers. Hopefully you're understanding the concepts and you're getting all the answers correct. Now let's move on to the final example. We are simplifying using the index laws. So, as we mentioned before, let's choose B. We have 10 to the power of 4 all to the power of 2. So 10 to the power of 4 is the base and 2 is the exponent. So for this type of scenario, we have to multiply the exponents. So that's the same as 10 to the power of 4 multiplied by 2, giving us 10 to the power of 8. Let's choose another example. Let's say A. Let's say G. So we have A power of 4 all to the power of 5. So 8 to the power of 4 is our base and 5 is our exponent. This is the same as A to the power of 4 multiplied by 5, giving us A to the power of 20. I'm going to give you 3 seconds to try and pause and solve the rest. 3, 2, 1. And here are the answers. Hopefully you got them right. And finally, let's do some final examples. So simplify using the index laws. Let's take, for example, G. So we have B squared power of 5. That's the same as B to the power of 2 multiplied by 5, getting B to the power of 10. Let's do J. That's m power of 4 multiplied by m power of 2 multiplied by m power of 3. So that's the same as m to the power of 4 plus 2 plus 3 because we're multiplying. And we get m to the power of 9. Let's do one final one. Let's do L. For L, we have g cubed power of 3 multiplied by g squared. So to do this, let's start off with g cubed power of 3. That's the same as g power of 3 times 3. And that is multiplied by g squared. So first of all, this, we get g to the power of 9 multiplied by g power of 2. And that's the same as g power of 9 plus 2, which is g to the power of 11. I'm going to give you a few seconds to pause, solve as much as you can, and then I'm going to show you the answers. 3, 2, 1, and here are the answers for you. Hopefully you got the concepts right and you're finding them easy to understand. Always remember, if you have any doubts, any questions, please leave them in the comments and I'll answer them for you in the next videos. I now want to highlight some big misconceptions. So let's take 2 multiplied by 3 squared, and on the other side 2 plus 3 squared. So these two look a bit similar, but the way you approach them is completely different. So for this, you can take the route of it's the same as 2 squared multiplied by 3 squared. So let's do each one alone and we'll see how they're similar. So for 2 times 3 squared, let's say we multiply them before we take the power into consideration. So it's 2 times 3, which is 6, all squared, which gives us 36. Now, let's take the other side. Let's say we expanded it. So it's 2 squared times 3 squared. We get 2 power of 2, which is 4, multiplied by 3 squared, which is 9. And if you multiply 4 times 9, you get 36. So as you can see, both methods, we get the same answer. When it comes to addition, lots of students get confused because we don't take the same method. So 2 plus 3 squared, whole squared, the correct way to do it is it's 2 plus 3, which is 5, and 5 squared is equal to 25. That's the correct way to do it. But if we expand like we did in multiplication, we'll get a completely different answer. So let's say we expanded and we said it's 2 squared plus 3 squared. Then we'll get 4 plus 9, which is 13. As you can see, the numbers are completely different. This is the incorrect way to do it, and this is the correct way to do it. So always double check. Make sure if it's addition or multiplication. because the methods you take will be different. Let me give you another example so that we make sure you've understood the concept. Let's say we have 5 minus 2 cubed. The correct way to do it is we take first what's in the parenthesis, so it's 5 minus 2, giving us 3, and the cube stays the same, and 3 cubed is 27. The incorrect way to do it is expanding first. Then we'll get, so it's incorrect, 5 cubed minus 2 cubed, because that gives us 5 cubed, which is 125, minus 2 cubed, which is 8. Giving us 117. As you can see, the numbers are drastically different. This is the correct way, and this is the incorrect way. So last example, using division, let's say we have 8 over 2 all squared. Then we could take two methods. Either we divide first and we get 4 squared, which is 16, or we can expand it first. So we can get 8 squared over 2 squared, which is 64 over 4. Gives us 16. Therefore, we end up with the same answers. So what we learned is that multiplication and division take on the same method, where you can expand or simplify inside the bracket and then expand to the powers. While addition and subtraction, you have to work from inside the parenthesis and then you introduce the powers. This is the method for multiplication and division. So if you want to save it in your notebook, here it is. So if n is a positive integer, then ab all to the power of n is the same as 8 to the power of n multiplied by b to the power of n. And a over b all to the power of n is the same as 8 to the power of n over b to the power of n, provided that b is not 0. Now that we have the concepts down, let's solve some examples. So let's choose b, for example. We have x multiplied by y all to the power of 3. That's the same as x cubed multiplied by y cubed. Another example is h, where we have 5 multiplied by a multiplied by b all cubed. Expanding this, we get 5 cubed multiplied by a cubed multiplied by b cubed. So 5 cubed is 125 multiplied by a cubed multiplied by b cubed. I'm going to give you 3 seconds and then I'm going to show you the answers. Pause and solve as much as you can. Always remember, practice makes perfect. The more you practice, the more the concepts will get ingrained into your mind and it's easier to remember in the exams. 3, 2, 1. And here are the answers. And whenever you're facing any trouble, just remember the rule written over here. So a times b all to the power of n is equal to a to the power of n times b to the power of n. I'm going to give you a few seconds to check your answers and let's move on to the next examples. So, in this example, remove the brackets of the following and simplify. If you need some help, here's the rule. Let's start off with A, where we have x over y all squared. That's the same as x squared over y squared. Another example is G, where we have 2 over a all power 4. That's the same as 2 to the power 4 over a power 4. And that gives us 16 over 8 power 4. I'm going to give you 3 seconds to solve, and then I'm going to show you the answers. 3, 2, 1. Here are the answers. Hopefully, you got them all right and you've understood the concept. And now let's move on to some a bit more challenging examples. Okay, so express the following in simplest form without brackets. Starting off with A, we have A times B over 2 all squared. That's the same as A squared multiplied by B squared over 2 squared. And expanding even further, you get A squared multiplied by B squared over 4. Another example, which is a bit more challenging, is D, where we have m squared over 4 all to the power of 2. To expand this, we first take m to the power of 2 multiplied by 2 over 4 power of 2. Do you remember the first rules where when you're raising a power to a power, you keep the base and you multiply the powers? That's what we did here. We kept the m and we multiplied the powers 2 times 2. And at the bottom we had 4 to the power of 2. We can expand this a bit further and we'll get m power of 4 over 4 to the power of 2, which is 16. Let's do one last example and go for G. In G, we have 4 a squared over 3b all squared. To solve this, we first expand the 2 into the 4 and the a squared. We get 4 squared multiplied by a power of 2 times 2, that in bracket, over 3 squared multiplied by b squared. We can expand this a bit further and we'll get 16 multiplied by a to the power of 4. over 9 multiplied by b squared. I'm going to give you a few seconds, try and solve the rest, and then I'll show you the answers. 3, 2, 1, and here are the answers for you with the rules if you need them. Hopefully you got them all right. And finally, here's a quick recap of everything we've learned today. So we have the base and the exponent or power or index. A power is usually, if it's a to the power of n, it's the same as a times a times a n times. And to multiply numbers with the same base, we keep the base and add the indices. Divide the numbers with the same base, we keep the base and subtract the indices. And when raising a power to a power, we keep the base and multiply the indices. If n is a positive integer, then a times b power of n is equal to a to the power of n multiplied by b to the power of n. And if a over b to the power of n is equal to a to the power of n over b to the power of n. Make sure to remember that when adding a plus b to the power of n or subtracting a minus b to the power of n, you take a different method because we'll get two different answers. Thank you for watching the video. I really appreciate it. If you found it helpful, please like, share, and comment what you'd like to see next. Part 2 should be out soon, where I go over how to deal with negative powers and exponents. And don't forget to subscribe below. Thank you for your time and goodbye.